Hey guys, all right, this lesson we're going to look at solving by graphing. There is an algebraic component to it, so I want to make sure that we cover that, as well as using Desmos in order to graph. So you can see for this method, I've got my note sheet open on the left and then my Desmos graphing calculator on the right. And it is asking me to find the axis of symmetry and the vertex, and then going to Desmos to graph it to verify those two things, and then using the graph to find my solution. Okay, if you are not asked to find the axis of symmetry or the vertex, you can go straight to graphing in Desmos. However, make sure that you're still showing evidence of how you found your solutions, which is just marking where those roots are, or the solutions, the x-intercepts, the zeros. That is going to be your evidence that you're going to turn in. If you want to graph it in Desmos and sketch it with paper pencil, that works too. So I'm going to go ahead and review the axis of symmetry and the vertex, and then we'll hop over to Desmos and graph them and find our solutions. Before that, at the top here, I have given you a visual of what it looks like when your graph has no solutions, which means it's above the x-axis. Should make sense because solutions, zeros are all x-intercepts, which means it doesn't cross the x-axis. One real solution is when your discriminant equals 0. That's where it touches one time. If your graph is reflected over the x-axis, then it would face down, and so it might look something like that. Okay, still one solution. And then two real solutions when your discriminant is greater than 0, where it crosses two times. Okay, and so what we're looking for on the solutions is this point right here. And then if there's no solution, sorry, I should have drawn one. It could be underneath the x-axis as well. Okay, and these have no solution, so our answer would be no solution. Okay, this guy can face downward too, as long as it intersects twice. Okay, let's look at our first example. We're going to do the axis of symmetry first. Okay, that's my x equals negative b, so negative 2 divided by 2 times a, and my a is 1. So my b is here and my a is there. Okay, and then when we simplify this, this is going to be negative 2 over 2, or a negative 1. So my axis of symmetry is x equals 1. Okay, so I'm going to go ahead and plug that in over here, x equals negative 1. And I'm going to go ahead and change that to a dotted line because I don't want it to look like it is actually my graph. Okay, then we can use the axis of symmetry to find the vertex. And the vertex is the lowest point or the highest point, depending on which direction it faces. And we're going to use our original equation with the value of x that we found, because remember your vertex is going to be on your axis of symmetry. So this is going to be f of negative 1, and we're going back to the original equation. Okay, so we have negative 1 squared, I'm just plugging in x, or negative 1 for my x's, plus 2 times the negative 1 minus 3, and then we can start to simplify. So negative 1 squared is 1, 2 times a negative 1 is a minus 2, and then carry down the minus 3. 1 minus 2 is a negative 1. Negative 1 minus 3 is a negative 4. So that tells me my vertex is at x is negative 1, y is negative 4. So I can go ahead and plot that as well. Okay, and I'm going to go ahead and put a label on here and call it v for vertex. Okay, and now we're ready to graph our equation, kind of get it all brought together. You can do this with a table where you do your x's and y's. I always use my vertex as the center point and then kind of go to the right 2 and the left 2 from there and plug in your values. And then we can also use Desmos and let it do some of the heavy lifting for us. So we'll do x squared plus 2x minus 3, and I forgot my f of x equals. I know you don't need it, but it is good terminology. There we go. Okay. F of x equals, and then I put an f of the n. There we go. Okay, you can see from my graph now that at this point I do have my vertex. Okay, the axis of symmetry does cut my graph in half, and then this graph is also giving me y-intercepts as well as the x-intercepts. Okay, now what I would expect to see on evidence is for you to go ahead and screenshot your graph. You got to include enough of your axes that you can see it all. Okay, and then we're going to paste it onto our evidence page. I'm going to run out of room for my other one, so I'm going to squeeze that in here. Okay, I could also sketch this by hand, and then I'm going to, let's grab a color that will stand out a little bit, maybe the purple. Okay, and I'm going to say that this point and this point, these are my solutions where x is, and if you can't remember what they are, you can definitely click on them. So x equals -3 and x equals 1. I don't know why I'm writing that twice. This would be my solution. Okay, so I had to show the evidence for the axis of symmetry in the vertex because that's what it was asking for. And then the graph is showing me how I'm using the graph in order to find the solution. Okay, let's see. I'm going to clear these out and we will go to the next one. Whoops. Let's see if I can. Give myself some more room here. Okay. Next problem. Let's switch to blue. Okay. We have -x² minus 10x minus 25. So my axis of symmetry is going to be at x equals -b, -10 over 2 times a, which is a -1. So this is a +10 over a -2 or a -5. And then I have to find f of -5. So -5 squared is 25. Minus 10 times a -5 minus 25. Okay, so when this is simplified, plus 50 minus 25. So -25 and -25 is a -50, so this should add up to 0. So that tells me that my vertex is at -5, 0. My x is here, my y is here. And I'm going to go over to Desmos and plot those. So I have an axis of symmetry at x equals -5. And again, I'm real quick just going to make that a dotted line. And then I have my vertex at -5, 0. And I'm going to label that with a V for my vertex. And then I'm going to plug in my equation. F of x, whoops, sorry. F of x equals -x squared. Notice the negative isn't inside parentheses, so only the x is getting squared, and then we have to multiply the negative after that. Minus 10x minus 25. Okay, and just to review real quick, you guys, this negative sign in front here tells me that my graph should be facing down. That is my A value. Okay, it faces down. My vertex is on my curve. My axis of symmetry does actually cut my graph in half, my quadratic, my parabola. And so that tells me that my solution is going to be right here at -5. Okay, so then again, take a screenshot and submit it over here, and my solution is going to be -5. I'm running out of room right here, so I am going to leave the screenshot on the right hand side of the video for you guys. Okay, this next one is our last one. Okay, so we'll go ahead and same thing here, guys. Let me switch colors one more time. All right, so my axis of symmetry, x equals -b, so -8 over 2a, which is a -2, so this is going to be 4. My vertex is at f of 4, so this is a -4 squared, plus 8 times 4 minus 17. So this is negative, and then 4 squared. Same thing, you guys. If the parentheses was around -4, you'd be doing -4 times -4. It isn't. It's outside of that. So it's 4 squared is 16 times a -1. Okay? Plus 32 minus 17. A -16 and a -17 is a -33, plus a +32 is going to leave us with a -1. So my vertex should be at 4, -1. Okay, I'm going to go ahead and turn those off. And we will say our axis of symmetry is x equals 4. And we're going to make this a dotted line. My vertex, is at 4, -1. And label that with a V. And then I'm going to write in my equation. So f of x equals -x squared plus 8x minus 17. Okay, there my vertex is on my curve, as well as my axis of symmetry cutting it in half. And then when I look here, I can see this is my x-axis here, right? And it's not touching the x-axis. So for this one, there would be no solution. Okay, go ahead and do the check your understanding. I would like for you to practice the vertex and the axis of symmetry, just so that it gets easier for you to connect that in. I will be looking for that on your evidence page along with the graph of your function. Let me know if you guys have any questions. This is it for the lesson 3 components. So we went through 5 methods, and then we have one more lesson this week to wrap up unit 3. Let me know if you have any questions, and I will see you in the next video.